All right, folks, we already did this slide, but I'm just going to take a second and review it because we're going to rely on the differences between homogeneous and heterogeneous mixtures and their specific definitions to talk about how we might separate them. So just as a reminder, homogeneous, remember homozygous meant the letters looked the same in biology, so homogeneous mixtures have a uniform structure or composition, aka they look the same throughout. Remember our example was black coffee, right? And again, you don't have to write this down. We're just using this as a review. So it's not like I can look at black coffee and say, oh, here's the coffee, here's the caffeine, here's the water, right? I can't separate it out. I can't see the differences. It just looks the same throughout. And so another way that we refer to that is a homogeneous mixture. When we compare and contrast that to heterogeneous, remember heterozygous meant that we had, for example, a capital B and a little b, right? And so those look different. And so accordingly, heterogeneous mixtures do not have a uniform structure or composition, right? If I'm looking at that chocolate chip cookie dough, I can very clearly see where the chocolate chips are and where the cookie dough is. I can clearly see the difference between those two. Or trail mix, right? I have almonds and M&Ms and raisins, depending, on the type of trail mix you have, but all of those look different and I can see the differences, and we would refer to that as a heterogeneous mixture. So the reason we looked at that is because sometimes we want to separate the components of different mixtures. We're going to do this a little bit in class. We're going to do this a little bit further down the road as well. So when we want to separate the components of different mixtures, there's several methods that we can use, which are summarized here. Those are listed down in your notes. We're going to go into each in a little bit more depth, but filtration, extraction, distillation, crystallization, and chromatography. So our first one, filtration, is typically used to separate heterogeneous mixtures, right? So again, things that I can see. If I have solids separated from liquids, this is typically really, really helpful here. So for example, we used black coffee as an example, but if let's say that all of the coffee grounds went through and I wanted to recover those from my black coffee, I could use a coffee filter to separate the coffee back out from that mixture. If I had a mixture of, let's say, sand and water, and I wanted to get the sand, and here, we'll write that out. If I had a mixture of sand and water, and I wanted to recover the sand, then I could run it through some filter paper. The sand is going to be left on the filter paper, water is going to go through. Most of you guys are comfortable or have filtered something in the past, and we kind of know how those work. Extraction, you probably haven't heard a ton about. We don't do it too much. If you go on to take organic chemistry, you're going to do lots of this. So extraction is used to separate two different liquids with different polarities. So remember, we can be polar or we can be nonpolar. And this requires what's called a separatory funnel. So basically, if I put a mixture, let's say, of oil and water together, we know that water is polar. We know that that oil is nonpolar. And so if I shake those up, eventually I'm going to get two different layers, right? I can have an aqueous layer, and I can have an organic or the polar or the nonpolar layer. So based on those polarities, if I separate them out, then I can get one liquid or the other. You guys have seen this. If you left a bottle of salad dressing and it separates into its oil and water, obviously we're not trying to recover one from the other there, but you've seen those different polarities. One floats on top of the other due to their density. If I am distilling something or using the process of distillation, this is used with homogeneous mixtures, remember, things that look the same throughout. And we can separate liquids with similar polarities but different boiling points. So if I had a mixture of water and a bunch of different chemicals, all of those chemicals are going to have different boiling points, and I can use that boiling, right? I'm going to boil this water with the mixed chemicals in there, and all of those chemicals are going to have different boiling points, and they'll boil off at some point in the process. This is the one, however, that we're really, really going to focus on. This is where I can separate dissolved solids from liquids. If you guys go to Target and you see distilled water, that water has been run through a distillation apparatus, and dissolved solids, like let's say there's salt in there, magnesium chloride, things like that. If I want pure water, then I can run it through a distillation apparatus and none of those minerals would be left over in my water. So I use this actually every day because my son has a humidifier in his room, and it turns out all of the stuff that's mixed in normal tap water can clog that humidifier. So distilled water, it doesn't have any of those minerals, it's not going to clog the humidifier. Crystallization is a specific type of distillation where dissolved solids are recovered from a solution, and this can be accomplished through saturation or heat. Don't worry about this one too much at this point. We're actually going to crystallize some salt at some point, and you guys will kind of see how that works. And finally, either the one that we're currently doing now or about to do is called chromatography. So we're separating compounds based on their polarity. So again, we're using that polarity as a differentiator. There are a couple of different types of chromatography. The ones that we're going to work on today involve paper chromatography. You can see we're going to create something that looks similar to that. But we can separate those compounds based on those characteristics, and this is another handy way to do so. So with that in mind, make sure that you're working either on that lab or working on the problems that they're in.